Good day to everyone. I am Alexis Ricafort with my classmates Lawrence Celorio and Evie Binay, and we are from Centro Escolar Integrated School of Manila, about to teach you the basic calculus, and the four topics that we will be discussing is integral and its rules, integration by parts, integration by substitution, and lastly, the definite. So, for the first topic, which is integral and its rules, let us first know what is integral. Integrals are also known as antiderivatives because you integrate derived functions back into its original form. As for the integral, we have four rules. First is the integral of k dx equals to k plus c. Now take note that in all integrals, their answer would always have a plus c on the end, for c is equals to constant numbers that are present in the given. For example, integral of 16x dx, the answer would be 16x plus c. Every number that only contains value in the x would only equal to itself. Integral of 1 over x is equals to ln x plus c. And for example, integral of 1 over square root of x plus 2 square root of x dx. And then, the next process will be the integral of x raised to negative 1 over 2 plus 2 integral of x raised to 1 half dx as we replace the square roots into its fraction form. We will now add the two rules to the solution. As you see, we have an exponent. We'll be adding plus 1 and make the equal as the denominator. And now, for the final answer, it will equal to 2 square roots of x plus 4 square root x raised to 3 over 3 plus c. Up next is to our second rule, is the integral of x raised to n dx equals x raised to n plus 1 over n plus 1. Integral of x squared dx is equals to x squared plus 1 over 2 plus 1 plus c. In our final answer, it should be x raised to 3 over 3 plus c. And on to our fourth rule and last rule of integral is the integral of e raised to kx dx is equals to e raised to kx over k plus c. For example, integral of e raised to 3x over e raised to 1 dx will separate 3x over e raised to 1 dx will separate the values since it would be more easier to solve the problem. It will be written as integral 1 over e times the integral of e raised to 3x dx. And now for the final answer, e raised to 3x over 3 plus c as we multiply both parts and bring down the exponent as the denominator.
For the next topic, we will be integrating function by parts. Integration by parts follow the formula. In this formula, you will choose which function will be u and dv. In choosing, we will be follow the LIATE rule, where R it means logarithmic, inverse, algebraic, trigonometric, and exponential function, respectively. You will pick the function in highest order as the dv and let the remain be the u. Then we will be derive u, so it's become du, and integrate dv, so it become b. Proceed to the first example. Let's follow what I said earlier. We choose which is u and dv in our equation. So we will let dv as cos sin x and x dx as our u. Then we will derive u, which is b du equals 1 and integrate dv, so the cosine x dx will be sin x. We'll now write the equation according to the formula mentioned earlier, so it is now raise integrate v du, so it will become negative cosine x, then the equation must be, then we will add a constant to the equation. The final answer will be, second example, we let e6x be dv and x as our u. Integrate dv, it will be 6x over 6 and derive x, so the remain is dx. We will now write the equation according to the formula. We will integrate, but first we can factor out 1 over 6 out of integrand, so we will just need to integrate is, then it's nothing left to do the equation but to simplify, so from it will be add c to the equation for the final answer. So the final answer will be,
the next topic will be integration by substitution. It follows the same concept of the chain rule in derivatives, but here we will integrate. The first example is the integral of the square root of 4x plus 3 dx. We can apply integration by substitution by letting 4x plus 3 as u and derive it so it becomes 4 dx. So we can see that there is dx in the equation, and we cannot go further into solving the function because we need to integrate everything in terms of u. To do that, we need to do something to make every variable into u. We can equate everything into dx. We need to divide both sides by 4, so it will become dx equals du over 4. Now that everything can be integrated in terms of u, we can proceed into solving this equation. Like the chain rule, we will now substitute everything in u. So, the integral of the square root of 4x plus 3 dx equals the integral of the square root of u times du over 4 dx. We will now transform the radical into its exponent form and copy everything else. In here, we can take away the constant, which is 1 over 4. And now, we can integrate u raised to 1/2. So by following the basic rules, it will now be u raised to 3 over 2 over 3 over 2. And we need to simplify everything. The final answer should be the square root of 3 over 6 plus c. For the second example, we will let 3x plus 8 be u and derive it so it will become 3. Like what happened earlier, there is again dx, so we will again equate it in dx. So it will be du over 3. As you can see, there is another x in the equation, so we cannot proceed. What can we do is use the value of u and equate everything into x. So it will become x equals u minus 8 over 3. Now we can substitute it to x and now we can integrate. We can take out the denominators, distribute u raised to 10, and then we take out 8 and we will integrate. It should be 8 over 9 times u raised to 12 over 12 minus u raised to 11 over 11. We will now simplify and substitute it to its original values and add c. The final answer should be 8 times 3x plus 8 raised to 12 all over 108 minus 8 times 3x plus 8 raised to 11 all over 99.
And now that we have finished discussing the integrals and its rules, integration by parts, integration by substitution, we will now go to the last topic for this tutorial. It will all be about definite integrals. Definite integrals have a lower and upper limit, so it will give you a specific value when you integrate. That's why we don't add c in the final answers. It follows the format of integral of the upper limit b and the lower limit a, as f prime of x dx is equals to f of b minus f a value. For this example, integral of the upper limit of 3 and the lower limit of 1, 3 dx. First, we integrate 3 dx, which will be 3x. Then we will now substitute x to the values of a and b and follow the formula. Perform the operations and the final answer.
The next example will be the integral of the square root of x cubed dx from 9 to 16. First, we need to integrate the function. So, like what we did in the previous examples, we will transform the radical into exponents and apply the basic rules. As you can see, we can simplify the equation by extracting the 2x squares from the radical. After everything has been simplified, we will now substitute x to the values of a and b and follow the formula. Simplify and perform the necessary operations, and the final answer should be 1562 over 5.